This is Geometry Lesson 10-5, Arc Length and Sector Area. Let's talk about arc length first. Typically we use the variable lowercase s to indicate that we're talking about arc length. Not sure why we decided on s, we just did. Arc length is kind of a bad name. I prefer using the name part of the circumference. So if you have a piece of the circumference, that is the same thing as arc length. So if you want part of the circumference, that means you want a fraction of the circumference. So a fraction needs to be some fraction of the partial angle divided by the total angle. So I'm going to call it the partial angle is r theta. The entire angle is 360 degrees. And that's going to be of. Whenever you see this word of, that always means multiplied. So this fraction is going to be multiplied by c. And hopefully you have that memorized. It is 2 pi r. There's your fancy formula that you're going to be using over and over again. And this is very similar for sector area. I've chosen the very bad variable of surface area or sector area. What type of area is it? I don't know. I'm just going to call it SA as opposed to just A. Most people online just call it A, but that's confusing between are you talking about sector area or just normal area. So again, this is just a part or a piece of the area. So that's a fraction of the area. And guess what fraction we're using? Well, it's the part angle over the total angle. So it's theta over 360 degrees, and we multiply that by the formula for A. A is pi r squared. So we have two formulas ready to go. Let's go ahead and see how we apply them. So first, in example 1, we're trying to find the length of the arc. So we're trying to find how far am I traveling around here. We're missing some critical information here. So let's go ahead and make the radius a random 5 meters. So in order to do this, we're just going to use our formula. This is one of those plug and chug lessons, unfortunately. And I'm going to do part of the angle. So I'm going to say that my S here is going to be equal to part of the angle. And let me just write the formula. It's part of the angle over 360 degrees times circumference, which is 2 pi r. So in this case, this is supposed to be a lowercase s. So let me come back here and say that this is a lowercase s. It still kind of looks like a capital S, but it's a lowercase s is going to be equal to our angle here is 300, and then we're going to divide that by 360. Technically, those are both in degrees, and that's going to be multiplied by 2 times pi times radius. The radius here is 5. We punch this into our calculator, and we are done. We want to round here to 1 decimal place, although you should know how to be able to reduce this fraction. I think this is like 5/6 or something like that. And then you could multiply that by 10, so that would be 56, and that would be 25/3. So it's 25 pi over 3. But if you don't want to do that in your head, so you could just use a calculator. You do need to know how to use your tools appropriately. So let's go ahead and open up our calculator, which is somewhere. I'm looking for a calculator, scientific calculator. Not seeing one. I have the Desmos calculator. Let's just go ahead and search for one. Calculator. We don't appear to have one, which is a problem. We'll just use the Desmos calculator, I suppose. It'll still work. And I'm just going to type in 300 divided by 360, and that's the fraction. And I'm going to multiply that by 2, and I'm going to multiply that by pi, and I'm going to multiply that by 5, and there's our answer. So we can say that this arc length S is approximated by, so wavy equal to sign, 26 point, and let's round in 1 decimal place, 2. Excellent. All right, we'll use that calculator in a sec. In example 2, we're trying to find the area of the sector. So sector area means a piece of the area. It's almost the same formula. It's the fraction times the area. So this is going to be the fraction. Let me write the formula for sector area. Sector area is equal to the fraction of theta divided by 360 degrees, and that's going to be multiplied by the area, which is pi r squared. So in this case, my sector area is going to be equal to 150 degrees divided by 360 degrees multiplied by pi times what's our radius. We don't have one, so let's go ahead and make one up. Let's just go ahead and say we're talking about 8 feet here. And I noticed that my last answer did not include my units. We have to be careful with units now. So if it says meters, we should probably say meters on here as well. We should say meters, and now I want to box that work. Down here, let's say it's 8 feet. So it's going to be pi times 8 squared. So from here, I just need to, again, use a calculator. Let's go ahead and split the screen, and we're going to pull up our Desmos calculator. Let's type in down here 100, that's not the 100, 150 divided by 360. I want to multiply that by pi, and then I want to multiply that by r squared, which is 8 squared, and we get our answer. We say that surface area is now approximated by this number. We're around to one decimal place, so it's going to be 83.8, and this is going to be feet squared. Ooh, squared. Why squared, Mr. Sandell? So whenever you have area is in a units, I'll write this down. This is units squared, and this one is just units. Units squared is talking about something, some surface that you can paint or that you can cover with carpet or something like that, whereas units is just a length, like how far on a ruler or how far do you walk, stuff like that. So just remember, surface area, something squared, and arc length is just nothing squared. I should box my final answer down here. And we've got it. That concludes lesson 10-5 for geometry's arc length and sector area. Thanks for watching.